Okay, so yesterday we talked about the coordinate plane and graphing and the x and the y axis. Today we're going to talk about functions and what makes a function a function. So the definition is that for every x there's only one y, or for every input, which is the x value, there's only one y value that it goes to. Okay, so we're going to look at some examples here. So this first set of points here, number one, we're going to draw a mapping diagram. So you'll see what that is as I go through here. So we're going to write down that 3 maps to 7. So we take the two numbers, okay, but we see here that this is a 3 and that's an 8. So 3 now also goes to 8. Okay, and then 3 goes to -2. And then 3 goes to 4 and to 1 as well in those last few points, okay? So this is not a function, okay, because this one input has more than one output. So these are the inputs and these are the outputs over here. And it can only have one output for every input. So let's look at something that probably is a function over here. So we're going to draw another mapping diagram, and this one goes from 6 to -7 as an output, and 5 to -8, 1 to 4, 5 to 5. Oh wait, look at. So before we draw this point in, this is a function. But now that this has 5 going to two different things, this is also not a function, okay? So if any of these numbers here repeat and they don't have the same output, it's not going to be a function. An example of a function would be, if we had 4, 2, 1, 1, 0, 0, 1, -1, -1, -1, that would be a function because none of the inputs repeat. Okay, so really all these numbers are different, so automatically we know that is a function. Okay, so sometimes we see it as this way, same thing, inputs and outputs, just in a different form. Okay, so the first thing we can look at is, look, all of these inputs are different, 0 through 4, and so automatically, yes, we know that is a function because there are no repeating inputs. Okay, if we look over here, they have inputs that repeat, and the big deal here is that they don't go to the same number. So 8 goes to 2, 3, 4, 1, 0. So this is not a function, no. So if it's the same number on the top, it needs to be the same number on the bottom. Otherwise, it's not a function if an input repeats. Okay, so again, let's look here. We have -2, 0, 1, -2 is our inputs. Oh, look, there's a repeating input right here. And this input has different outputs right here. And so this is not a function because it has two repeating inputs with different outputs. Okay, we can also look here if it's just a list of points and say, okay, 0, 1, 2, 3, all different inputs. So automatically, yes, that is a function because there are all different inputs. Okay. Again, we're going to look here, -2, -1, 0, 1, 2, all different inputs. So yes, that is a function. We don't even have to look at the outputs. If the inputs are all different, then it is automatically a function. Okay, -2, -1, -1. Oh, right here, I see -1 has an output of 0 and -1 has an output of 1. So it's a different output. So automatically, that is not a function. Okay, so when we have points or tables or maps, we're looking at the numbers. We also can look at graphs and decide if those are functions, okay? So we use what is called the vertical line test, and that's when you draw a vertical line and see if it goes through more than one point. Okay, if it goes through more than one, that's the important piece, more than one point, it is not a function. So for example, this vertical line here with the red dotted line, it only goes through one point on that function, okay? This vertical line here on the second graph goes through 2 points. So again, if it's more than one, that is automatically not a function, okay? But it can also go through less than 1, because I could draw a vertical line right here on this function, and it would go through 0 points. But what you want to try to do is find somewhere where it would go through more than 1, because that's what's going to prove that it's not a function. Okay, so for example, on this first one, number 3, if I drew a vertical line, I want to try and get it through as many points as possible, and I see that if I draw it through right here, that goes through 2 points. So that is no, it does not pass the vertical line test. Okay, but no matter where I try on this graph here, I can draw a vertical line, and it's only ever going to go through 1 point at a time on the graph. So yes, this would be a function because it passes that vertical line test. Okay. The other thing we talk about when we talk about functions is domain and range. Okay, so a domain is just the input values, okay, and the range is just the output values. And we just make a list or say a range of numbers that represents that. So again, the domain is just the input values and the range is the output values. Okay, so for example here, the inputs are always the x, so this is going to be where we find the domain is the x's. So we see that there is a point at 0. There is a point where x equals 1. There's a point where x equals 2, 3, at 4, and at 5. So our domain would be 0, 1, 2, 3, 4, 5. Our range, however, there's only a couple y values that have points, would be 3 and 4, okay, because those are the only y values where there's points. All right, this one's a little different because it's continuous. Okay, so for this one, it starts at right here at -3 and goes all the way up to where x is equal to +3. So we would say from -3 to 3. Okay, the range starts where y is equal to 0 and it stops where y is equal to 3. So this one would be 0 to 3. Okay. The last thing that we're going to talk about here is independent and dependent variables, okay? So the independent variable for our purposes is always going to be the x if we have an equation in slope-intercept form, and the dependent is always going to be the y, because whatever you input, because the input is the independent variable, and then the output is going to be the dependent variable, because whatever we input for x is going to tell us what y is, and so y depends on what x is. Okay, so we're going to look at this function, and we don't have an x and a y here, but this is still in slope-intercept form. We just have an a and a b instead. So you can think of it would be in y equals mx plus b form. It's just got a b and an a instead. Okay. So that y equals mx plus b form. Okay, so this function, a equals -4b plus 14, represents the number of avocados you have left after making b batches of guacamole. Okay, so the number of avocados depends on the number of batches of guacamole. Okay, so our number of avocados is dependent on how many batches of guacamole we have. So our dependent variable is going to be A, avocados, and the independent variable is going to be B, batches of guacamole. And then, so that is because, again, the number of avocados depends on how many batches of guacamole we make, okay? So if we were to make an input-output table, our input would be the number of batches, and the avocados left would be our output or our dependent variable, okay? So we're going to plug some numbers in. If I make 0 batches of guacamole, I need to plug that in here and say, okay, 0 in place of the B plus 14. So negative 4 times 0 is 0, and 0 plus 14 is 14. So our output would be 14. So if we make 0 batches of guacamole, we have 14 avocados left. If we make 1 batch of guacamole, I'm going to do that one down here, and plug it in as well. So negative 4 times 1 instead of 0, because that's from our equation, would give us negative 4 plus 14, which is 10. So we would have 10 avocados left after 1 batch of guacamole. If I make 2 batches, I'm going to do negative 4 times 2 plus 14. So that's negative 8 plus 14, which gives us 6. So that's 6. Okay. And then if I make 3 batches of guacamole, I'm going to do negative 4 times 3 plus 14. So that's negative 12 plus 14. So that's 2. And so that's our output. Okay, and the reason I chose 0, 1, 2, and 3 is because it says if the domain is 0, 1, 2, and 3, so if our input, because the domain is always related to our input, is 0, 1, 2, and 3, then our range is the outputs for those numbers. Okay, so the range would be 14, 10, 6, and 2. Okay, so this is our range for those. And most correctly, oh no, we'll just leave it like that. So our domain is 0, 1, 2, and 3 because again, that's the inputs. All right, and the range is going to be the outputs. Okay. I'm going to go back and review really quickly. So it's going to have, if we're looking at a function, regardless of the form, there's going to be 1 output for every input. Okay, so for every x, there is only 1 output. Okay, and we test that a number of different ways. We can use a mapping diagram. And remember, with the mapping diagram, we only want 1 arrow coming away from the input. So this can't happen and this can't happen. Okay, remember when we're looking at a table, if an input repeats and it has a different output, that's not okay. That makes it not a function. But if all the inputs are different, then it is a function. And then if we have points, as long as all the inputs or the x values are different, then that is a function. And if they are the same and they have different outputs like these guys here, remember that's what made it not a function. Okay, and then for any graphs, we do the vertical line test. And if it passes through more than 1 point, like this guy does anywhere on the graph, that is not a function. If you can draw a vertical line and it's 1 or less, then that is a function. Okay, and then when we talk about functions, we talk about domain and range, and really important, remember domain is input and range is output. Okay, and then last, independent and dependent variables. To sum that up, the independent variable is what you plug in, and the dependent variable is what depends on what you plug in. And so y is usually a function of x in our case. And again, if it's in y equals mx plus b form, it doesn't matter what letters are here. Our example had an a and a b in it, but this is going to be the independent variable, and this one's going to be the dependent variable. Okay. Please try to look over those notes, fill in your notes, and let me know if you have questions. Then try the Big Ideas assignment for 3.1.